afternoon, everyone. My name is Siddesh. I am from Nitya Meenakshi Institute of Technology. I am studying in AIDS branch. Uh, my capstone project was forest fire detection system. I named it as a PyroGuard. This is actually a AI-powered fire forest detection system. This is an emergency response system actually. It is an The system analyzes live webcam frames to identify fire and non-fire images and frame by frame. And when potential fire is detected above the defined confidence threshold, it alerts the system and gives the guidelines. This is actually a good project where we can see a project overview of it detects the fire using custom CNN and verifies the detection using the fire resistance timer. Actually, of 3 seconds of verifying it is taken. It will detect fire for 3 seconds. Then it actually tells the fire confidence, threshold fire confidence. And as you can see, project overview. There are two key features and two classes, fire and non-fire images. Actually, the dataset was too low. It was only for 1,000 images, but I took some random images from outside buildings, color images, orange, because this model was not trained properly. So I took some normal orange images, orange red images. Every images I took and I trained the model, and as you can see, I trained about 3,000 images. Uh, this is my data set. These are the fire images. And these are my non-fire images. And I have done my model using fire detection model, which is a Keras model that is a TensorFlow. And when it comes to backend, yeah, this is the code where I clean my data set because there were so many photos which were corrupted. So I clean my data and data set analysis. Analyzing the data is more important in this type of projects because fire and non-fire, there must be a, like if it is smoke, it also detects, it should also detect fire. If it is not there, smoke is also not there, it can't be like that. So I clean my data set analysis, and this is a data pre-processing. This is a split of data set. I splitted the whole data set into train, test and validation folders, and I separated that into fire and non-fire images. And this is actually a training process. Loading the data set, data augmentation and image parameters that is by 224, 224, a batch size of 32. And I trained my data set. I'll show you. Evaluating the model. This is a model evaluation. This is a pre-processing of the data set. And this is actually the training of the model code. And I trained my model, image size of 224 and 224 resolution, and batch size of 32 with epoch of 20 epochs, and every epoch consisting of 22 images. And that was my first email, like first time train. And the second time I trained using some normal random images as a non-fire images. That took 66 images for training per epoch. And this is an evacuation AI component where this gives the evacuation guidelines after it detects the fire. and this is the code for the alarm, for which after detecting the fire, which gives the alarm sound. And this is a timer for fire timer, verifying for 3 seconds, delay of 3 seconds because it should verify. And this is a screenshot for every fire detected photo frames. It takes the screenshot and heat map for generates and heat map for that picture and loads into the result section. Yeah, this is the accuracy and validation graph, training and validation accuracy graph, as you can see here. And I have used early stopping in this program, training the model while training the model, because early stopping may help us in help us more not to overfit the model. Model might overfit because of the more images and training full photos. And this is my classification report. And test accuracy, I got 88%, 7.4. The training accuracy was 92.76. This is my class confusion matrix, which detects 98% of the images correctly, and one out of all images it detects one wrong image, and 16 false images, and 36 correct images. This is my training versus validation loss. This is a validation loss graph. And this will be the example webcam GradCam image, and the screenshot of that image is here. This is the original picture. As you can see here, the fire is detected here, and the GradCam detects in GradCam it detected the fire. As you can see, the orange color, it is the fire detected here. And this is the code of full integrated program. This is fully integrated code where I connected all my prediction and live prediction training and screenshots, confusion matrix, everything. I integrated to this program, and I'll show the live. As you can see, it is detecting no fire, confidence of 93.880, and it is safe. Heat map is waiting because it not detecting any fire. Right now, I'll show you the fire picture. See, it is verifying the fire. It is verifying the fire. And as you can see here, in the gradients are successfully installed, and guidelines are saved into the latest guideline text. And I'll show you the web page. And this is my web page where you can come to know how much of the fire was seen in the picture. 68% of the fire was seen in the picture. Alarm was activated, and these are the emergency guidelines for the people to evacuate the building or the place immediately. And this is the fire evidence where fire was detected, and this is the grad cam image or heat map where the actual fire was shown in the picture. And this is all result. As you can see, the training accuracy was 92.2%, test accuracy is 88.7%, and fire precision is 98.9%. These are my graphs plotted. This is training versus validation accuracy graph. This is training versus validation loss graph. This is confusion matrix and the classification report of the whole project. As I told you guys, first thing there, it detects 98 pictures currently, and missed fire was 16, and actual no fire was 36, and false fire alarm was 1. Yeah, this was all about my project PyroGuard. Thank you guys.